Students, we are doing the example center of mass. Welcome to NQuest Physics students. Previously it is known as Quest Head of Physics. Okay, today we are going to do one more problem which is on center of mass. Here you see it is a lamina. What's the lamina? It is a thin plate. That too, it is a thin flat plate. Thin flat plate is known as a lamina. That too, it is a regular lamina. Watch it. Let's go with the dimensions of this lamina to understand the things very easily. I'm taking it is one of the block and it is another thin plate. Actually, is the first thin plate and second kept one over other. Let's say it has a length of L that is equal to 2 meter. I'm taking numericals. Okay, students, and its breadth, take it as 1 meter. Okay, students, in the same way, it is the breadth of the second plate. It's of 1 meter, and its length, say it is L2, it is equal to 1 meter. Obviously, it would be 1, and it is what? 2, 1. These are the two plates. Let's say they have the masses of M1 and M2 respectively. Is a problem, students. He is asking us find the center of mass of the system with respect to O. Here I am locating O. Here it is. We have to find out the coordinates of center of mass with respect to this. As usual, you know that center of mass can be had as XCM is equal to M1 x1 plus M2 x2 upon M1 plus M2, and similarly YCM is equal to M1 x1 Y1 plus M2 Y2 upon M1 plus M2. It's a two-body system. First, what we have to do? First, we have to locate the center of mass of the two plates. Okay, students, where it lies. Okay, we have to locate the geometrical center since they are regular shaped bodies. What's the joining the chord? What's that? Diagonals. And here is the centroid. Okay, students, in this case we have the same. Extend this. There is the diagonal. There's one more. Okay, it is a centroid. By help of these two centroids, we have to find the coordinate, students. Let's say it is a coordinate. These are the x1 and y1, and for this x2 comma y2. Okay, students, here this length is obviously equal to x1 through the center here, and here it is y1. Getting me, students? Similarly, x2, see what I am doing. It is x2, and here up to here it is y2. Okay, students, let's find the magnitudes of x1, y1, and as well as the x2, y2. x1, see, it is the geometrical center. The length is 2 meter. It means here this distance, half of the total length is the x1. That is x1 is equal to L1 by 2, and you get 2 by 2. It is equal to 1. It is 1 meter. Okay, students. Similarly, we have to find out the y1. y1 is equal to b1 by 2. Is the b1 1 meter, 1 by 2. It is half meter. Okay, and we have to find out x2. See this, it is the x2. Okay, this distance, that means what? x2 is equal to x1 by fourth part of this. See this? Okay, x1 is equal to how much? No, fourth part of the L1, this one, half part of the x1, that is 2 by 4. It is 1 by 2 meter. Okay, students. And y2, this one, it is 1 meter and it is half meter. 1 plus half, it is 3 by 2 meter. Okay, students, we have the coordinates x1, x2 and as well as the y1 and y2. Then after we have to go with the masses. It is the first block I said. If you watch it carefully, mass is directly proportional to area since it is a thin plate. That means you can write m1 is proportional to a1, okay, and m2 is proportional to a2. a2 is the area of this plate, a1 is the area of this one. Then what we had, m1 is proportional to a1, means area of this 2 into 1, 2 square meter, and a2 is equal to m2 is proportional to a2, this one, 1 into 1, it is 1 square meter. Okay, we had the areas and as well as the masses. Then just we are putting the values in. That is xm is equal to m1 x1 plus m2 x2 by m1 plus m2. Let's put the values. xm is equal to m1 we had, it is 2 units into x1 into 1 plus m2, here we have got it is 1, and x2 here it is 1 by 2 plus 1 plus 2, it is 2 plus half by 3, okay, it is 5 by 2 by 3, it is 5 by 6 meter. In this way you can calculate the coordinates of center of mass xcm as the 5 by 6 meter. And similarly you have to go with the ycm. ycm is equal to m1 y1 plus m2 y2 by m1 plus m2. m1 obviously here we have it is 2, it y1 we got it is 1 by 2 plus m2 it is 1, and y2 is equal to 3 by 2 by 1 plus 2, it is 2 by 2 plus 3 by 2 by 3. Okay, students, 2 by 2 1 plus 3 by 2 by 3, 2 5 by 2, okay, by 3. Okay, students, these are the coordinates of center of mass xcm and as well as the ycm. In this way we can solve these kind of problems. Okay, students, let's do one more problem. Here this time we took a lamina which is in the C shape. Okay, let us see. It is made of 3 rectangular flat frames, that is, it is a 1, is a 2 and is a 3. Okay, let they have the masses of m1, m2 and as well as the m3. Okay, students, they have the dimensions 2 meter, 1 meter. This area you know that. Similarly it has 2 in 1 and it is 2. Okay, it is a 2 meter. We have to find out the center of mass with respect to one axis. It is, as usual, you know that the coordinates can be had as xcm and as well as the ycm. Let's say it is the 1. Okay, we are locating the coordinates. It is geometrical center and obviously it is x1. Okay, the same thing goes with this also. Okay, students, it is x2. Okay, and it is x1 I told you, x1 is equal to x2, that is equal to 1 meter. Okay students, and similarly we have to find out the y1. It is y1, it is half meter. Okay, and if you go with this, the geometrical center, then it is, that's the x3, isn't it? It is x2. x2 is equal to half meter. Okay students, then we have to go with the y2. y2 is equal to, it is 1 plus 1, 2 meter. And similarly we need to find the y3. It is y3. Okay students, it is 1 plus 2, 3 and half. 3 and half means what? 7 by 2 meter. And we have to find out the masses. It is 2 into 1. m1 is equal to m2. It is equal to, what you get is directly proportional to area, 2. Okay students, 2 units, you can take it as a kg. And this one, 2 into 1. Okay, m3 is equal to 2 units. Just substituting the values in, what you get? xm is equal to m1, x1 plus m2, x2 plus m3 x3 by m1 plus m2 plus m3. Put the values m1, m2. Okay, all have the same masses. That is m of x1 plus x2 plus x3 by 3m. mm get cancelled. Okay students, x1, what we have? x1 is equal to x3 is equal to 1. 1 plus half plus 1 by 3. It is 2 plus half by 3. It is 5 by 6 meter. Okay students, similarly we will get the YCM. YCM is equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. That is, mass is same, m of y1 plus y2 plus y3 by 3m, where mm get cancelled. That is y1 plus y2 plus y3 by 3. Let's take y1. y1 is equal to half. Okay, half plus y2, 1 plus 1, 2 meter, plus y3, 1 plus 2, 3, 3 and a half means 7 by 2 by 3. Okay, okay students, it is 24 by 4 by 3. It is 8 by 3 meter. In this way you can find out the XCM and YCM as 5 by 6 and 8 by 3 meter. Okay students, here's the method to find out the center of mass of 3-body system. Here by using the same method you can find the different structure, students. Let's do one more problem in center of mass, students. Here in this problem, it is a structure which is made of 3 blocks. It's a 1, 2 and 3. Let's name this block is 1, it is 2 and it is 3. Okay students, we have to find out the center of mass of this block with respect to the origin which is kept here. Okay students, let's say the length of this entire base is 4 meter. You can take any value. And similarly, say it is the same, it is 4 meter. Maybe they look weird and say this length is 1 meter and it is 2 meter and it is 1 meter. Obviously, let's take this height of this block is equal to 1 meter. Okay, students. Okay, students. Here we consider these blocks as 1, 2 and 3. And as usual, the center of mass of the three body system along the x-axis can be written as xcm is equal to m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. And similarly, ycm can be had with the same notations, m3 y3 m1 plus m2 plus m3. First of all, we have to find out the masses and as well as the positions. As you have learned before, mass is directly proportional to area since the density of the material is constant. Okay, you know that density is equal to mass by area density. That is, mass can be written as, in this way. Mass is proportional to area. Let's take this one. We have to find out the mass of this structure. It is the length is equal to 1 and breadth is 4. Let's say it is m1. m1 is proportional to 4 into 1. 4 units. Okay, students, the same way we have to find out the m2. m2 is proportional to, we are just using the same 2 meter into 1 meter. 2 into 1, it is 2 units. Obviously, m3 also has the same value of the first one, 1 into 4. Okay, students, 4 units. We know the masses. Okay, students, m1 is equal to 4, m2 is equal to 2 and m3 is equal to 4 units. Let's find is that position of the particles, that means what, bodies with respect to the origin. If you take this block, see this, we have to find out the geometrical center. Obviously, it is geometrical center. Okay, students, and it represents the y1. Okay, students, and this part, this distance is x1. If you watch it carefully, it is totally 1. Then x1 is equal to 1 by 2 meter, and we get the y1. Since the length is 4, this height is 4, and y1 is equal to half of that, it is 2 meter. We had the coordinates x1 and y1. Similarly, we have to go with this and locate its geometrical center. Okay. Here I have to do the same thing. In this way, I have to locate. This is a geometrical center. Here also it is a geometrical center. And it is height. Okay. Obviously, if you say it is y2, y2 is equal to, the total height is 1. Here I showed it is equal to 1 by 2 meter. And we need to find the x2. Often we confuse it over. Maybe it is the x2, but not. Here from the origin you have to measure. It is 1 plus the total length is 2 plus 1. Means what? 1 plus 1. Okay, it is equal to 2 units. We had the x2 and y2, and finally we need to find the x3. Okay students, here the same thing is happening. Okay, and if you go with this and join the diagonals, the met at a particular point, it is the same as y1, it is y3, obviously it is 2 meter, and here measure this, it is half, it is 1 plus 2 plus half, 3 and half. Okay, means 7 by 2 meter, and y3 is opposite, it is 2 meter. We got the values of the coordinates, that is x1, y1, x2, y2, and x3, y3. Just it is a substitution. Then put the values in. xcm is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, and take the value of the m1. m1 is 4, and we are taking the x1, it is 1 by 2, and m2 2, and we had the x2, it is somewhere into 2 plus m3, here we have it is 4 into x3, already we got it 7 by 2 by 4 plus 2 plus 4, it is 2 plus 4, 2 ones to 2s plus 14 by 4 plus 2 plus 4, 18 plus 20, 6, 10, it is 2 meter. Okay students, in the same way we have to find out the YCM. It is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. We call it as the YCM students. Let's substitute the values. m1 obviously it is 4, and take the y1 we have here, it is 2 meter, plus m2 is equal to 2, and y2 we had y2, it is half plus m3, same as that, by m1 means what, 4 plus 2 plus 4, here 2 to get cancelled, it is 8 plus 1 plus 8 by 10, 17 by 10 is 1.7 meter. In this way you can find out the center of mass of the U-shaped body. We did few examples of that, and I hope you understood how to calculate the center of mass of a thin lamina. Okay students, in next part of the video we are going to do the problems in center of mass of continuous body. That means what, we will do some little bit of integration. Okay, with that we will find the center of mass of various structures like thin rods. It seems like with respect to one axis it seems like this. It is a thin rod. Okay, we have to find the center of mass with respect to any position. Let's say it is L and M. We'll go through that one. In the same way, we will find the center of mass of a thin rod which is bent in a, or the shape of a semicircle, and also we find the center of mass of thin plates. It is the plate. Here in next part of the video we are going to learn about these kind of structures students. If you like my videos, please subscribe my channel and forward the channel to your friends. Okay, and my suggestion students, watch the videos till end, then you can understand the topic very well. Thank you for watching my channel.